Yeah, and then like you guys are gonna be gone for a week.
Yeah. So, there's not gonna be any quizzes or anything while we're talking?
No, if any quizzes or anything will be online,
Okay.
so we won't have to mess with that one. Okay, so this is problem 47. All right, we have a force that's going diagonally through the block. Okay, a force that's going diagonally through the block, and the force has a magnitude of 100 newtons. And we want to determine the moment of the force about point A, and we're going to do it by doing RB. We're going to do it two ways. We're going to do it by using RB, and we're going to do it by using RC. This is one of those cases where knowing where you are in the book and knowing how they want you to solve it is going to give you that practice. So the first thing that we got to do is we got to draw our force vector. So our force vector is going to be 100 newtons times our unit vector. And if I'm drawing my unit vector, I've got to look at my x, my y, and my z. So my x is 0.4, okay? So this, we've got 0.4 in the I direction, but look at the direction of the arrow. It's pointing in the negative direction on I. My y, okay, it's pointing in the positive direction for y, and that's 0.6j. And it's pointing in the positive direction for k, and it's 0.2k. So is everybody comfortable with that position vector? It's not a unit vector yet. It's just using the coordinates right off of the block to give me, to start to get my unit vector. We good? So now, the magnitude of my r vector is going to be the square root minus 0.4 squared plus 0.6 squared plus 0.2 squared. And that should be something like 0.7483. So F is going to equal 100 minus 0.4 divided by 0.7483 in the I direction, plus 100.6 divided by 0.7483 in the J direction, plus 100.2 0.7483 in the K direction, which should end up being minus 53.5, 80.2, 26.7. Everybody agree with that?
I don't have my calculator, but yeah.
All right, so I'm going to write out RB and RC. So RB is just, look at the arrow in the picture. That's the first thing. RB is going to be minus 0.6 in the J direction. RC is gonna be minus 0.4 in the I direction, plus 0.2 in the K direction. We good? So if I want to do the moment at A using RB cross F, that's just going to be I, J, K, 0 minus 0.6, 0, and we get minus 53.5, 80.2, 26.7. And that will work out to be minus 16 in the I, minus 32.1 in the K, and that's Newton meters. If I do MA R cross RC cross F, that is I, J, K, minus 0.4, 0, 0.2, my minus 53.5, 80.2, 26.7, and that'll end up being minus 16 I, minus 32.1 K. So you can give yourself a way to check problems. So this problem was just about calculating the moment. And we were spinning the box this way, around that axis. You good? So we're going to do a practical problem. We're going to use a board to hold the end of a 4-way lug wrench. We're going to step on it. The force that's going to be applied is 100 newtons. We want to determine the magnitude of the moment produced by the force about the x-axis. Okay, we're going to do it, the magnitude of the force produced about the x-axis.
This one, like, are you recording right now?
Yeah,
Okay.
and it's still recording. This morning, apparently, we lost internet connection and my recording stopped halfway through class and didn't know it. Right now, it's flashy. Okay, so if I want to redraw this picture so I know what's happening, there's my RAB, okay? I have a force, and you see the force that's being applied. It's a 60-degree force. So I've got my force being applied, and we know that that's 60 degrees. Okay, this point right here, this is point A, and that point is at 0.2500. This is at 0.25.250. Because I'm at 25 millimeters this way, 25 millimeters that way. This is in the plane of my XY plane. And this is the point that we're looking at, so that's 0.25, 0.250, because it's in the plane. So everybody comfortable with those two position vectors? And this becomes RAB. So as Brandon did it one time when we were doing one of these, he went ahead and used the technique where you take your 0.25 minus 0.25 in the I direction, plus your 0.25 minus 0 in the J direction, and then I've got 0 minus 0 in the K direction to get my difference between my 2 points, and that gave me 0.25 in the J direction. You could have also done this one by inspection. Okay, because if I'm doing RAB, let me draw it on the picture here. If I'm doing RAB, that's RAB. And since there's nothing in the X direction on that vector, it's only in the Y direction, I could have just written the 0.25J. So this, my force, right? That's 60 degrees. It only has a Z component and it has a Y component. So my force is going to be 100, because we've told it's a 100 Newton force. Cosine of 60 in the Y direction. It's facing downward, so I got to do a negative sine of 60 in the K direction, which is going to give me 50J minus 86.6K. Everybody comfortable with that? See how I got there? So now we just do RAB cross F. And this is about the I direction, so we're going to do it that way, okay? Because we want to do it about the I direction. So this gives me 1, 0, 0, 0.250, 0.50 minus 86.6. And that ends up being minus 21.7 Newton meters. I could also do it with mx, where we did our force times our distance. And if we're doing it about the x-axis, see if I can draw the picture so this is going to be minus 100 sine of 60 times my 0.25. The other one, that's plus, we'll do it plus just so you can see it, 100 cosine of 60, except it's in the plane of what we're doing, so that's 0. And that's going to give me minus 21.7. So you can do it either way. There's our picture. You can do it either way. Did that one.
Could we have done it the, just RAB cross F and just only took the I component? Would it still have worked? I do know.
In this case, probably because you got zeros everywhere. I don't know that it will always work.
Yeah.
All right. We have a signpost.
That's a lot of things.
So we have two couples that are acting on the frame, right? We got that one, and we got that one. It is in equilibrium. Okay, it is in equilibrium. We want to find D. So if the resultant couple moment has to equal 0, and we want to find D. So the sum of my moments has to equal 0. The first couple, the 50-pound force, if I'm looking at it like this, that's my perpendicular, oops, sorry. That's my perpendicular piece, okay? Let me draw this better. Have this. We're given that that's 30 degrees. And this is my force. This is 3 feet right there. This will be my force cosine of 30 degrees. So I'm going to have 50 cosine 30 degrees, 3 feet. If I do the other one, because I'm going to do 4/5, it's going to be 4/5, my 80, times the distance that I'm trying to solve for.
Should our 50 cosine of 30 be negative because it's in clockwise?
Yep. You're correct. Then, we just do 50 cosine 30 times 3, 4/5, 80 times d. D is equal to 5/4, 50 cosine 30. Got a 3 out here divided by an 80 out there, and it works out to 2.03 feet.
Yeah, that would look a lot more intimidating than.
Yeah.
That's-
Okay. Got 2 wrenches acting on a pipe. We want to express the moment of the couple acting on the pipe. And what's its magnitude? So what I gotta find is RBC. Because I need to know this distance right there. And you can do that a number of different ways. Okay, number of different ways, but if I do from here to here, that's 2.5. That's in the J direction. Everybody okay with that? All right, and then I've got from here to here is 3. And that's in the I direction. Now the thing is, you gotta take a which way you wanna go, all right? If we go this way, okay, we wanna rotate it this way so that that's positive. This needs to be a minus 3I minus 2.5J. Now, if we're just finding magnitude, we don't necessarily have to worry about it so much, right? Because it's just the distance between the two. And but if I do that, then I get M, the moment couple is RCB, which is what we did. We did RCB crossed F. is gonna be I, J, K, minus 3, minus 2.50, and that's a 20 in the other direction. There's my 20. And then I will get minus 50I plus 60J. And then that's just the square root of 50 squared plus 60 squared. That's gonna equal 78.1. And that's pound feet in this case.
And we should get the same answer if we do it.
I think we should get the same answer. One will end up being,
Well, we are squaring it.
yeah, you're squaring it over here, so. For the magnitude, but if you want the actual vector, you gotta do it the other way. All right. Same type of problem. We need to figure RAB. So if I'm going from A to B, I'm gonna be 0.3 in the Y, and I'm gonna be 0.2 in the X, and both of those are gonna be positive. If we're told that F is equal to 125 newtons, we get RAB cross F. R is 0.2 in the X direction. I plus 0.3 in the J direction. And we're going to cross that with 125K. And that will ultimately end up being, the magnitude will end up being 45.1. Making sense? I'm going to stop there. No. Although I do need Madison's.
Did you get them?
Because I can take it to
Technically not supposed to let you do that.
Really?
Changing the,
All the way down to-
number 6. Yeah.